In this video, we are going to evaluate some limits of some sums. So here, the way that we're going to do that is we're going to compute the sum first, and then after we've computed the sum, we will find the limit of the sum. So here we have the limit as n goes to infinity of the sum I equals 1 to n, 12I plus 1 over n squared. So how are we going to do this? Well, first we can factor out the constant. So here, that value 1 over n squared, in terms of the summation, that is a constant. It's not changing. The thing that in the summation that's changing is the letter I, and it's going to go up to n, but that value of n, it's not changing in the summation. It's changing in the limit, but not in the summation. So we can bring it out of the summation. And now we can apply our limit rule, or our summation rules. So 12I, sum from 1 to n, is going to be 12 times n plus 1 over 2. 1 summed from 1 to n is just 1 times n. So we have a limit as n approaches infinity of 1 over n squared times 6n times n plus 1 plus n. The limit as n approaches infinity, 1 over n squared, 6n squared, plus 7n. So we have a limit as n approaches infinity of 6n squared plus 7n over n squared. So what is that limit? Well, here we have one polynomial over another polynomial. These two polynomials have the same degree, so n squared and n squared. And so the limit, as we approach infinity, is going to be the ratio of the leading coefficients. So it's going to be 6 over 1, or just 6. Right, so this is like a 1 right here. And we get a value of 6. That is our limit. So as we approach infinity, we're adding this infinite number of terms up. That summation is going to approach 6. Perfect. All right, let's look at another example. So the second example, we'll look at it. So here we have a limit as n goes to infinity, sum I equals 1 to n of 2 plus 3i over n squared times 3 over n. All right, so what do we have? Well, the 3 over n, in terms of the summation, that is constant. So we have a limit as n approaches infinity. That 3 over n we can bring out in front. Sum I equals 1 to n. 2 plus 3i over n squared. We can't apply any summation rules at this next step yet because of the squared, so let's go ahead and square it out. So if we FOIL that out, we'll have 4 plus 12i over n plus 9i squared over n squared. So that's what we have there. So now we have a limit as n goes to infinity. We have our 3 over n. Now we can apply our summation rules. So we could split this up to a sum I equals 1 to n of 4 plus 12 over n, sum I equals 1 to n of I. That's 9 over n squared, sum I equals 1 to n of I squared. And now we can apply some more of our rules. So for our constant, if we add that constant together n times, we just have 4 times that upper limit, the constant times that upper limit. Then we'll have 12 over n times n plus 1 over 2. That's our summation rule for I. We have 9 over n squared times our summation rule for I squared is n times n plus 1 times 2n plus 1 over 6. And if you've forgotten those summation rules, you can go back a couple of videos. We had looked at those. Here are the summation formulas that we are making use of. Here I made use of this formula and this formula, so our I squared formula and the I formula. Perfect. And so we have a limit as n approaches infinity of 3 over n times 4n plus 6 times n plus 1 plus 3 times n plus 1 times 2n plus 1 over 2n squared. Let me make those brackets. Good. And so, continuing on with this, we would get something like so if we were to multiply that 3n through, we would have 12n plus 18n plus 3 plus, let's see, we'll have a 18n cubed this part's going to be over 2n squared. This part is just 2n cubed. So I have an 18n cubed plus 18 n squared plus a 9n squared plus 9n and if we evaluate that, then we will have 12 plus 18 plus 18 over 2, which is 39. Where I get the 12 plus 18 over 2. Here on top, this is like a 12n plus 18n over this n, so our leading coefficient is really 12 plus 18 on top over 1. On the second piece, we have an 18n cubed and a 2n cubed on bottom, so that's where, as n goes to infinity, we have the 18 over 2. Right. Now, I know on the first video from this section, not this video, but the very first one from this section, I said we are going to look at areas. We will finally start looking at areas in our next video. I will see you there.